Today is a continuation of what we did in 6.2 where we were learning all these properties of parallelograms. Now what we're going to do is we're going to turn those properties into methods to prove to prove a quadrilateral is a parallelogram. So it's kind of going back to proofs a little bit, just a little bit. All right, so here's the deal. Yesterday we had a list of all these properties. And these properties really were theorems that we had, and it's kind of like when you do the converse of a theorem, like if you have a parallelogram, then opposite sides are congruent. If opposite sides are congruent, then you have a parallelogram. It's kind of like doing the converse deal. So of those list of properties that we had yesterday, let's look at which ones actually can we use to prove that our quadrilateral is an actual parallelogram. All right, so I'm going down this list, and what I did is on the flow chart, and I don't know if you have the flow chart or not, depends on, I don't know, if you were there yesterday, whatever. If you have the flow chart, I put an asterisk on all the properties that actually could be used to prove that it's a parallelogram. So one of them is prove that both pairs of opposite sides are parallel. Well, that's the definition of a parallelogram, so yeah, that would make sense that would prove that they're a parallelogram. If you can prove that both pairs of opposite sides are also congruent, that would prove that it's a parallelogram. All right. This property here, prove that an angle is supplementary to both of its consecutive angles. So in this picture you can see this 105. If you can prove that it's supplementary here and also supplementary here, then we would have a parallelogram. Prove that both pairs of opposite angles are congruent. All right, so these are all the properties here that we've come across. Prove that the diagonals bisect each other. If you can prove that, you've got the parallelogram. This is the one new one that's a little bit different. It's not really one of those properties. It says prove that one pair of opposite sides is both congruent and parallel. So you can see in this picture, if you can prove it's parallel, you don't have to worry about these. And also prove that these are congruent, then you know that you have a parallelogram. All right, let's look at it. Now, deciding whether the quadrilateral is a parallelogram. It's set up like it's a proof. We're not going to really do like this two-column proof thing. We're just going to kind of talk through it and see what we think. And we're supposed to decide if it is a parallelogram. All right, so if they give us this information here, and it's already marked in the picture, and then they tell us this information, already marked, we're trying to prove it's a parallelogram. So of those different reasons on that previous slide, which ones do we have going? Well, I see the opposite sides are congruent. Got that. I would need these sides to be congruent as well, but I would be nervous about that. I don't really have any information there. But remember that last property, if I can prove that this set is congruent and parallel. So let's see if we can work on the parallel piece. If these are parallel lines cut by a transversal, what kind of angles are these right here? They're same side interior. Okay, and same side interior angles are supposed to be parallel. And we have this theorem that says that if the same side interior angles are, I think I said parallel, I'm sorry, they're supposed to be supplementary. If the same side interior are supplementary, then the lines are parallel. And looking at this, 50 plus 130 is 180. They are. So that would be my process. If I were going to do this two-column proof thing, I'd say that these two lines are parallel because if consecutive interior angles are supplementary, then the lines are parallel. Then I could say this is a parallelogram based on that last property on the previous slide. I showed that one pair of opposite sides is both parallel and congruent. All right, let's look at B. All right, again, all the given already marked up for us. Is this a parallelogram? Okay, looks like it's an opposite sides kind of thing because that's all that's given to us, nothing about angles. But notice what happened here. This is not opposite sides congruent. It's like consecutive sides congruent. And we don't have anything in our list that talks about consecutive sides. It's consecutive angles have some properties, but right here, I'd say no go. I could not prove that this is a parallelogram because it's not the opposite sides. Okay, so just some more of this. Why would this be or would this not be a parallelogram? Okay, so I'm going to take a minute and let you look through these and see if you can decide if yes they are or no they're not and why. So take a minute, pause the video, and see if you can figure these two out. Okay, let's look at this first one. I went ahead and started it for us. What I'd be looking at is two lines cut by a transversal. And when I do that, you have to look at which angles are created. This line I didn't draw over, so we're not talking about that angle. We're talking about this double marked angle. Same thing up here. These double marked angles are alternate interior angles. And if the alternate interior angles are congruent, then these two lines are parallel. Now if I erase all of that off of there, and oh, it doesn't let me erase it, sorry. Okay, so I can't erase it, but if I were to go do the same thing with the other pair, and let me change up the color, maybe we'll do that. If you do these two lines and the transversal, now you can see you've created this angle and you've created this angle, and now it's the other pair of lines. I think I could show this as a parallelogram by its definition. I could show that both pairs of opposite sides are parallel. All right, on this next one over here, you see what's marked up. Again, I think I'm in that boat where they're trying to mix two properties together. I have one set of parallel sides right here, but it's the other set that's congruent. I would need both of those congruences in parallel to happen on the same side, so this would be a no-go. All right, so let's move on to, it says use the diagram at the right. For what values of x and y must this be a parallelogram? So thinking through that, I got all these angle measurements is what they've given me. And I have to think, well, if I want it to be a parallelogram, what do I need those angles to do? And there's a couple ways you can look at it. You could say that opposite angles would have to be congruent. So I could set this equal to this, and then come back, and I have to, both sets have to work, so then I'd have to set this equal to this. Now here's the deal. Did you notice that when I said this equal to this, that you're talking about an x and a y in your equation? And then this way you'd have another x and a y, which we can work through. We did it the other day where we had x's and y's and we solved the system. But we might be able to make our life a little bit easier. It does also, one of the other properties says that consecutive angles have to be supplementary. Well, these both have a y in them, and that'd probably be easier for me. If I want these to be supplementary, then I could take this plus this and make it equal 180. And then over here, if you look at these two consecutive angles, they both have an x, and I could do the exact same thing over there to figure out what x equals. Okay, I'm going to start with the x. I'm going to make the consecutive angles supplementary, so 4x plus 13 plus the 12x plus 7 needs to all add up to 180. And then I've got to clean up the left side, combine your like terms there. And then I'm going to subtract the 20 to the other side. And then I'm going to divide by 16. X is equal to 10. All right, now I want you to do the same thing for the y's. Go ahead and pause the video, see what you come up with. Okay, here's what I ended up with. Did the exact same thing, set it equal to 180. I got y to equal 43. If you did too, let's keep moving. If you did not, take a minute and fix what you might have done wrong. The rest of our notes today are just going to be construction notes, and as always I kind of have to just try to show you constructions just by freehanding them here. I'll use colors to try to help, but what we're working on is constructing parallelograms by using any method of those ones that we talked about today. First one, probably the easiest way to construct a parallelogram is to make the opposite sides congruent. It's a little bit like how we did an equilateral triangle, where you make all the sides a certain length. Here's what I would do with this one. And you can do this in your construction notes. If you need to pause the video and go grab those, do so. Ultimately, what I'm going to do is I'm just going to start off and make this some length. Don't know how long, don't really care. But then I'm going to put the point of my compass on this end, and I'm going to put an arc down here determining how long I want that to be. All right. Then I'm going to do a random line up this way. And I'm going to designate that to be a certain length. And I'll probably just make it shorter. I don't want to make it the same length because then that makes it a little bit more special. Make it a different length. So I'll put the point of my compass here and make an arc out there. Now that measurement right there that I made, I need a side over here to be that exact same measurement. So since I have that, my compass opened up to this length right here, I'm going to go ahead and use that one right there. I'm going to come over here, put the point of my compass here, and I'm going to put my arc out here. That is that same length that I just got done making. So then put an arc out here. Again, putting the point of your compass at that spot you decided. Okay, you make that arc. So that's going to force, I can draw anywhere to that arc and it's going to be the right length. But I also need the top leg up here of my parallelogram to be this exact length. I need opposite sides congruent. So I'm going to go back to this and I'm going to remeasure that with my compass. Go ahead, put the point here, put an arc through here, make sure it really goes through there nice. And once you have that to that appropriate length, then you put the point of your compass here, and then you make an arc out here, and you're looking to create that X. If you get this X created, that's that last vertex that we need. And once you have it, then you can just start connecting parts, and there's your parallelogram. You just made opposite sides congruent. All right, let's try another way to do this, and you can kind of decide when we get done like which way seems to be the easiest for you. We're going to do it by its definition. We're going to make opposite sides parallel. All right, now we don't want to make this a specific type of parallelogram, which we'll talk more about throughout the rest of the chapter. But be careful about when you're like, don't make things perpendicular. We kind of want them at weird angles like parallelograms tend to be. So I'm going to start off, again, same thing, going to make my random line down here. And then I'm going to do my random line this way. Now, I got two of the sides done. It's the other two sides that I have to purposely construct as parallel. Now, I probably should have made this a little bit longer. Go ahead and extend yours. Give yourself plenty of room there. This is really just the construct parallel lines construction. So I've got this. Now what I'm going to do is I'm going to just decide some random place up here. How long do I want this side to be? I'll just put a dot there. That's where I want it to be. Now I'm going to copy this angle here. Ultimately what I'm doing is I'm going to make corresponding angles congruent so the lines are going to be parallel. I'm going to copy this angle and mark it up here. So pick some random arc measurement and swoop through this angle. You're putting the point of your compass here, swooping through that angle. Then you come and copy that process. So you put the point of your compass here and you swoop through. And then what you do is you decide, well, how wide is this angle at that swoop? So put the point of your compass here, undo that. Don't do that. Let me fix that. You put the point of your compass here. It doesn't really matter on this one, but it will on the next one. Put the point of your compass there, measure how big your angle is, get an arc through there. I'm going to look for that arc so I know you measured how wide that is. And you copy that process up here. Put the point of your compass here, and with that exact same measurement, you're going to put your arc through here. All right, now with that arc, you're going to be able to, you created that X thing that you need, and you're going to be able to create this side. And it's going to be parallel to the bottom side because you just made corresponding angles congruent. Now, it would be super tempting at this stage to now just kind of make the opposite sides also congruent. That would probably be an easier process, but we're going to go ahead and stick with the theorem we're trying to use here, opposite sides parallel. So I've got the top and bottom parallel. Now what I'm going to have to do is create another angle. So I'm going to come over, I don't know, here let's put it right here. Put a dot here somewhere. And now what I'm going to do is I'm going to copy this angle here over here now. So I got to go back, and if you want to keep it the same, that might be easiest. And after you've done this a few times, you really could like copy this angle twice all at the same time, and then you're not adjusting your compass so much. But put the point of your compass here and get this to be the right measurement to match that one. And now you're going to put the point of your compass here and draw that exact same arc. I goofed that up. I should have made that line longer. Right? That's why I kind of always exaggerate those lines, because you just never know how long you want that to be. Okay, now I'm going to go back and I'm going to measure how wide this is. So back to putting the point of your compass here. Measure this out, get that arc in there. You can also go the other way. I had started to do that. You can put the point of your compass here and measure this way. Doesn't matter, it's the same width. But when I come over here, I'm going to have to put the point of my compass right here and transfer that distance up there. So I'm going to put the point of my compass here, put my arc up here, create that X, and then I'm going to be able to draw in that last side. And now I've made all those sides parallel that I needed to. Now think about this for a second. So the next time you do this, maybe this would be easiest. You go ahead and make your two lines to begin with, and you're going to copy this angle. So you make this red arc, make this red arc, go ahead and decide, you know, we just randomly picked that point, and we just randomly picked that point. So randomly pick those, and then make that arc and make this arc at the same time. Then you're never having to like adjust your compass. Then you're going to come back and measure how wide it is. And at that point then, you've got what you need to go ahead and measure how wide it is, measure how wide it is. You're doing it all in one shot, so you're not adjusting your compass. Just a thought. All right, last one. This is kind of a combination of those two ideas is what this is. We're going to make one pair of opposite sides, and I'm going to do the top and the bottom, parallel, and I'm going to make them congruent. Here we go. Random line down here, random line up here, and I'm going to make that, I'm going to do that parallel line thing again. Now I only have to make one pair of parallel sides, so I'm just going to do it once. Put the point of my compass right here at this little vertex and swoop an arc through. Now we're going to randomly choose some place up here. Don't know how big I want this to look, so randomly pick some point there, and you're going to swoop that same arc, put that point there, and that same arc swoops through again. Now you're going to measure how wide this is, so put the point of your compass here and see how wide that arc is. Put the point of your compass up here, copy that, make it the same width. Now you got the X that you need to draw your line through. Now what I have right now are opposite sides parallel. One set of opposite sides parallel. I haven't done the other side yet. Okay, but I want one pair of opposite sides parallel and congruent. So I get to just randomly pick some measurement. How long do I want this to be? Okay, I'm just going to swoop through, put the point of your compass here, swoop through out here someplace. That's how long I want it. Come up here, put your point here, mark that exact same measurement right here. Now I know that those two sides are also going to be congruent, and I can connect those, and boom, I've got not only parallel, but also congruent sides. All right, that's all I've got for you. Good luck.